Hello, good day. So today we're going to be doing the can't place flowers on LeetCode. So let's just get into the description there. You have a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plots. Given an integer array flower bed containing zeros and ones, where 0 means empty and 1 means not empty, and an integer n, return true if n new flowers can be planted in the flower bed without violating the non-adjacent flowers rule, and false otherwise. So if you just look at the example here, so we see flower bed equal 10001 and equal 1. So the output is true because we can at index location 2 we can plant a flower. We can plant one flower in this array, and that would mean that we planted 1, so n equal 1, so we put true. If n is equal to 2 here now, there are not enough spaces to plant these two flowers, so we return false. So just look at any constraints there. So we know that we don't have to look for anything besides 0 and 1. There are no two adjacent flowers, so we don't have to check and see if there are any adjacent flowers and replant or anything like that. So should be relatively, those constraints are pretty good there. So let's just get started. So in the input here we have flower bed equal in and we have it will be the integer array, and n is the amount of flowers that we have to put in, and our output would be the bool if you can or cannot. So basically what they're asking is to check if there are enough strings of three zeros such that all the flowers given by n can be planted without having any ones next to each other. So basically the minimum amount of zeros that you need is 3 in order to plant a single flower. Well, not minimum really, it has some edge cases that we'll get into. But essentially, given that the array starts and ends with a 1, we need 3 consecutive zeros to even plant 1. So moving on there, the length of the flower. So many cases that I thought of were the length of the flower bed is 1, the flower bed starts with a 0, flower bed ends with a 0. We'll have to handle these cases a little bit separately, and the flower bed has all zeros. So the algorithm that I came up with is we need to do there's 3 parts to this. If there are, so this is basically going to be our pre-loop check here. This shouldn't be here. So this is going to be our check here before we go into our big for loop. And basically we're going to check to make sure if the flower has a length greater than 1. If it doesn't, then what we're going to do is we're just going to append 0 to this, to the start and the end, so that we can still go through our loop, because remember we still have we don't want to handle that edge case too specifically, because I don't look that wouldn't be like, I just didn't think that it'd look proper. So what we're gonna do is we're just gonna append a 0 and a 0 to the end to kind of act as that quote unquote just so that we could go, so that the range of the length of the array would still be enough to still go through this loop here. So append 0 to the start and the end, because remember that the value here could still be 1, or the only single value could be 1, or it could be 0, and n could be 0 or n could be 1, because we know that n could be less than equal to, from the constraints, less than equal to 0, greater than equal to 0. So now the next thing we want to do is we want to look at the index. If the index is 0, if index 0 and 1 are not planted, then we plant something at index 0. So this is to handle our case here. The flower bed starts with a 0, and then we just decrement n. So that's how we're going to be keeping track of if enough flowers can be planted. We're just going to decrement n, and we'll know if all the flowers are planted if n is less than or equal to 0. So for I, and then this is a big loop here, so for I in range 1, length of flower bed minus 1, so we know that we want to go through to, we want to start to do 1 because we already populated this here. So in this case, we know that the first character is going to be 0, so we want to start from 1. And in this case here, we know that if something's not planted, then we're going to plant something at that index, so there's no need to check it. So if the flower bed, so now we're going to check the flower bed behind, we're going to check the flower bed in front, the current flower bed, and then we're going to check the one in front if they're all zeros. And if they are, then we're just going to plant it, so this would be 1. We're just going to plant it there, and then we're going to decrement n. And if the last 2 indexes are consecutive zeros, then we just want to decrement this again because we know that we could plant one there. So this was a implementation I had that was I just didn't like how it looked. My actual answer probably doesn't look any better. But what I decided to do was, so in this check here, I kind of grouped up this and this into this for loop here. So it was doing a lot of unnecessary checking, and it made it look a little bit like there was just like way too many ifs here. So this is the actual implementation that I came up with. So if the length of the flower bed is less than, so oh yeah, right. So the first thing we're gonna do is check that the length is more than 1. So if the length of our flower bed is less than or equal to 1, then we wanna append to the beginning and the end, so that we can still go through this loop without going out of range. Look at the start first. We want to see if the first flower is a 0, and if the second one is a 0. If the first one is a 0, then we're just gonna plant that flower bed at 0. We're gonna plant a flower in the first index, decrement n, and for iron range, start at index 1 to the length, so that we don't go out of bounds. If the flower bed, if the previous index value, if the previous value is 0 and the current value is 0 and the following value is 0, then we want to plant and decrement, and we're just going to do this for the entire loop. And then at the end, we'll just come back and check if the flower bed length minus 1 is equal to 0. If the last two values are 0, then we just want to plant 1 at the final value. Actually, no. This should be, actually we don't even have to plant anything. That doesn't really need to be there. That was wrong anyways. And we just decrement this and then we return if n is less than or equal to 0. It's not the most efficient way to do it, but it works. Yeah. So in terms of time, we only have this one for loop here that's going to be going through 1, so we're looking at O(n) time. We don't do any manipulation of the actual, we manipulate in place, but we don't actually create anything else, so it should just be, we're just using that structure that they gave us, so it's whatever size that is. So yeah, thank you.